Alright everybody, here's our next video on section 1.3. This is going to be your trig functions, trig ratios we should say, and right triangles. Right triangles. Okay, so here we have a right triangle. And we learned in geometry that this is our right angle, and across from the right angle is the hypotenuse, and each one of these sides is a leg. And a lot of times we would label each leg A and B and the hypotenuse C. And so if we knew any two sides, we could find the third side using the Pythagorean theorem. The Pythagorean theorem, which was A squared plus B squared equals C squared. So if I give you this triangle, if I say, here's our right triangle, this is 23 feet, this is 27 feet, what is H? And we want to find the area of this triangle. Well, area of a triangle is 1/2 base times height. So our height is what we're looking for. So we need to use our Pythagorean theorem. And C will always be across from the right angle. And solve. And so you get 529 excuse me, sorry for that, plus H squared equals 729. So H squared equals 200. So take the square root of both sides. And so H is going to approximately be 14 feet. Okay, so once we find H, which is 14, we can very easily find our area, which is going to be 1/2. Now what is the base? Our base is 23. And our height is 14. So multiply that out, and that would be 160 square feet. 160 square feet. Now, suppose we have right triangle. And I tell you this is angle theta. Okay? Then the hypotenuse is still across from the right angle. This is side A, this is side B, but we have specific names for this. The angle, the side across from the angle, well, this is called the opposite side. The side that's right next to the angle is called the adjacent side. So we can get some ratios for this. What we say with trigonometric ratios is that the sine of theta is going to be B over C, which is the opposite side over the hypotenuse. The cosine of theta is going to be A over C, which is the adjacent over the hypotenuse. And the tangent of theta is going to be B over A, which equals the opposite side over the adjacent side. So the way we remember this, Oscar, if you look O over H, A over H, O over A, Oscar had a heap of apples, if you remember that from your high school geometry class. Now, we say cosecant. Cosecant would be the reciprocal of sine. Okay? So it's going to be your hypotenuse over your opposite. Secant is going to be your reciprocal of cosine, which is your hypotenuse over your adjacent. And cotangent is going to be the reciprocal of your tangent, which is your adjacent over your opposite. Your adjacent over your opposite. Now this is all true as long as theta is an acute angle greater than 0 but less than 90. All this is true as long as theta is an acute angle. Okay? All this is true as long as theta is an acute angle. Now, since this is, if we look at the triangle, well, let me go to the next page so it doesn't take so long to write it. If we look at this triangle here, well, we know that this angle here is 90 degrees. So that means these two together would have to be 90. So if this is theta, then this other angle is 90 minus theta. Does that make sense? Because all the angles on the inside of a triangle have to give you a 180. So if we know this is 90, this is theta, then this other one has to be 90 minus theta. Of course, with our C, our B, and our A. Okay? So here's what we know. We know that sine of theta equals B over C. Now, this would be the same thing as the cosine of 90 minus theta. So if you look up here at this angle here, to get this B over C relationship, it would be the adjacent over the hypotenuse. So that would be the cosine. So sine of theta is the same thing as the cosine of 90 minus theta. Those would give you the exact same thing there. Okay? So we can say the very same fact for tangent, which is B over A. That's the same thing as the cotangent of 90 minus theta. And as far as secant goes, secant is C over A, and that's the same thing as the cosecant of 90 minus theta. Now, these are complements. That's what we call them. So, what we refer to these a lot of times is these are called cofunctions. Cofunctions, okay? Because of this complementary relationship that they have, they're called cofunctions. Now, we also have a reciprocal relationship with these. If you take the cosecant of theta and you multiply it times the sine of theta, well, cosecant is C over B. Sine is B over C. So that gives me 1. So because of that, we can say this, that the cosecant of theta is the same thing as 1 over sine theta. Okay? Same relationship with secant theta and cosine. Same relationship with cotangent and tangent. So these are reciprocal. So we say that secant theta is 1 over cosine theta. And we say that cotangent theta is 1 over tangent theta. 1 over tangent theta. So what you need to do is you need to practice being able to type some of these in your calculator. Now, you have to make sure, right now we only know degrees, but when we get to radians, you'll need to make sure your calculator's in the right mode. Right now, your calculator just needs to be in degree mode. Make sure your calculator's in degree mode before you type things in the calculator. Sine, cosine, and tangent, those are going to be, sorry about that, those are going to be pretty straightforward, typing it in the calculator, okay? Pretty straightforward. The only difference is, if you were to have something like the tangent of 54 degrees, 37 minutes, we would have to change this back to decimal degrees first, then take the tangent of it, okay? So in your calculator, you would actually be saying tangent of 54.6166. That's 54 degrees, 37 minutes back in decimal degrees. So that's how you would do that in the calculator. Now, not too worried. You can look in your book on page 26. It shows you how to type it in the calculator if you have a TI-8384. If you don't, look at your instruction manual to learn how to type these trig functions in your calculator. But one thing I will say, the ones that people get confused, hardly anybody gets sine, cosine, and tangent wrong when they type it in the calculator. But secant theta, or cotangent theta, or cosecant theta, when you type it in the calculator, you need to type this as 1 over cosine theta. So for instance, if you had the secant of 54 degrees, you would want to type this in the calculator as 1 over the cosine of 54 degrees. Okay? Keep that in mind. You don't have a secant button on your calculator, or you shouldn't. If you do, you probably have a calculator that's too high on the list, like a TI-89. You shouldn't be using those. Okay, so, but most calculators do not have them, so you have to rewrite them with the reciprocal functions like we did here. One thing I don't want you to get confused is there is an arc cosecant or an inverse cosecant button on your calculator. This right here, folks, is not 1 over cosine. That's not 1 over cosine. This is the inverse, not the reciprocal. This is the inverse. And what the inverse gives you is, let's suppose I tell you that sine theta equals 0.3174. So in other words, I gave you the answer, and now I want you to tell me the angle. If I'm looking for the angle, then this is where we use the inverse. The inverse will tell us the angle every time. Okay? The inverse will tell us the angle. So it would be, if you punch that out, it should be 18.506 degrees as an angle. Okay? So inverse is used to get the angle. So notice up here in all these other ones, I gave you the angle, and you would find the answer here. Okay? Here I gave you the answer, and I would want you to give me the angle. And it's kind of like I equate it to using multiplication and division. Multiplication gets you one answer, but if you want to go backwards, you have to use division, right? Same thing here. If you want to know the answer, you're using sine of the angle. But if we have the answer and we want the angle, we would have to use the inverse to go backwards. Okay? So you can practice typing that in your calculator. There's several of those on page 28 in your book. This is one way you could see it done. I could also write this exactly like this. I could write it as arc sine. Arc sine and inverse sine are the same thing. Arc sine and inverse sine are the same thing. So this and this are both the same thing. So don't let that confuse you, okay? But there's some you can practice with that on on page 28 in your book, okay? Since that's a calculator-based activity, I'll let you do that, okay? Now, let's actually solve some triangles. So, for instance, we have this triangle. We know that this is 124 meters. This angle is 35.7 degrees. This is a right angle. This is A. This is B. All right. So I want to solve this triangle. Solve the triangle. And when I say solve the triangle, folks, I mean everything. All the angles, all the sides. So I would need to find this angle as well. And these two sides here. And these two sides. Well, it's easy to find this other angle. If you remember our complement rule, this would be at 35.7 is angle theta. So to find the other angle is 90 minus theta in a right triangle. So this would be 90 minus 35.7, which would be 54.3. So this would be our complementary angle here. Okay? This would be our complementary angle. Now, what about the sides? Well, we have the hypotenuse. Okay? We have the hypotenuse. So, because of that, I know that I'm going to either be using sine or cosine. Okay? So, to solve for side B, I'm going to use sine of theta equals B over C. Because I know theta is 35.7. That's what I was given. And I know C. C is 124. So essentially what we have here is B equals 124 times the sine of 35.7 degrees. Okay? So when you multiply that out, you should get 72.4 meters. So that's side B. Now, to solve for side A, I wouldn't use Pythagorean theorem. You can, but those numbers are very large. And so I would stay away from that if I were you. What I would do to solve for side A is I would do the cosine of theta equals A over C. So since I know 35.7, it was given to me, I would use the cosine of 35.7. And we know C. C was given to us. So very similarly, this will be A equals 124 times the cosine of 35.7 degrees. And this will be our letter A, our side A. Okay? And so this would be 101 meters if you solved it. Okay? So we've solved for all the sides of this triangle. All right, let's try another one. And there could be a variation of these problems, okay? So don't be careful about this because I can give you any variation of sides and angles, okay? It just comes with practice. So this is where homework practice is going to come in very handy for you. All right, so let's look at this one. Here's our triangle. Theta is this angle. The hypotenuse is 51.3 kilometers. And the opposite side from theta is 47.2 kilometers. And this is A. And we know this is a right angle. So, solve the triangle. Alright, well, the first thing I notice is I have an angle. I need to know what theta is so I can get this third angle here. I have to know what theta is so I can get the third angle. Well, the only way for me to solve theta is to think about what I have represented. I have my opposite side and my hypotenuse. So what trig ratio represents the opposite side and the hypotenuse? Well, that's sine of theta. Sine of theta represents the opposite and the hypotenuse. So sine of theta equals 42.7 over 51.3. So I have sine of theta, if you divide that out, equals 0.832. Well, remember back just a moment ago. I've given you the answer. I want the angle. So how do I find that angle? Theta equals the inverse sine of 0.832. The inverse sine of 0.832. So if you do that, that should be 56.3 degrees. And make sure to pay attention to your problem, whether or not it wants these degree measures in minutes, seconds, decimal degrees. So this particular problem, in the directions, let's just say it wanted it in degree, minutes, seconds. Okay, it wanted your angle in degree, minutes, seconds. So we would have to change this back, this decimal degrees, back to degrees, minutes, seconds, which would be 56 degrees, 20 minutes. 20 minutes. Okay? 56 degrees, 20 minutes. Alright, well, I have my angle theta. Now let's find the other angle. So my complementary rule says that 90 minus theta will give me my other angle. So 90 minus 56 degrees, 20 minutes. Okay? If you do that subtraction, that's going to be 33 degrees and 40 minutes. Remember, 20 and 40 give me 60 minutes, which gives me 1 degree. 56 and 33 give me 89. So that's how we're getting back to that 90 if it's confusing you. We're just subtracting it off there. If you need to, you can always say 90 minus 56.3 and get the decimal degree answer here, and then change it to degrees, minutes, and seconds if that confuses you. Okay? So we've solved for both angles in degree, minute, second form like I asked for here. I told you I wanted it in degree, minute, seconds. Now we just have to solve for side A. Okay? We just have to solve for side A. So, excuse me. So here's what I'm going to do. Excuse me on that. I'm sorry, folks. I'm going to use tangent theta just so you can see another one being used. Tangent theta equals B over A. So what is theta? Well, we figured out that theta was 56 degrees, 20 minutes. Now, you're going to have to change that back to decimal degrees anyway to type it in your calculator. So I'm just going to go ahead and write that as 56.3. Since we already know the decimal degree version of it, I'm going to use that to type it in the calculator. Okay, keep that in mind. Now, we know the opposite side from theta, but we do not know A. So 42.7 over A. So if you do your cross multiplication and division, you should get A to equal 42.7 divided by the tangent of 56.3. Okay, so punch that out, and that should give you your letter A of 28.4 kilometers. Okay, so we just solved all sides of that triangle. So that's basically what we're going to be using these sines, cosines, and tangents for here in the beginning, is solving sides of triangles. Okay, be able to solve in any kind of form I give you, and so that's just going to take practice, right? The next section, section 1.4, will be applications of this same concept. So we will not be doing anything necessarily new in the next section. As a matter of fact, it'll probably mainly be me working problems for you. Okay, uh, application style problems for you, so that you can see what it's going to look like. So keep that in mind and have a great day.